Today we are going to solve the problem 2.6 of Griffith third edition Introduction to Quantum Mechanics. Before going to this lecture, please refer my earlier problem 2.5. Here the problem 2.6 is although the overall phase constant of the wave function is no physical significance, it cancels out whenever you calculate the measurable quantity. The relative phase of the coefficient in the equation 2.17 does not matter. For example, suppose we change the relative phase of psi 1 and psi 2 in problem 2.5. That is, psi of xn0 is a multiplied by this linear combination of psi 1 and psi 2. Here, only difference between problem 2.5 to this one is we have introduced a phase vector of e power I pi. So now you pi is some constant. Now you find the time dependent wave function and the square of the time dependent wave function. Also take the special case pi is pi by 2 and pi is pi. What will happen to this? So first we will normalize this wave function. Normalization for normalization, modulus a squared integral between minus infinite to plus infinite, modulus psi 1 squared, psi 1 psi 2 star uh, plus psi 1 psi 2 star plus psi 2 star psi 1 plus modulus psi 2 squared dx is equal to 1. So here, due to orthonormal property, this will go away 0. This will be 0 and this also will be 0. And this is 1 modulus psi square. If you integrate, this also will be 1. So you will get 1 plus 1, 2. 2 modulus a squared is equal to 1. So naturally, a is equal to 1 over square root of. So the time dependent wave function is 1 over square root 2 psi 1 e power minus I omega t psi 2 of x e power minus 4 omega t. We have seen in detail in the problem 2.5. So here only the extra term is e power base factor e power I pi. Then this can be written as 1 over 2. If you square it, modulus square of this one will be 1 over 2. If you take the modulus square of this exponential term will go away. This will become simply psi 1 modulus psi 1 square and modulus psi 2 squared. And the cross term you have two times because psi 1 star psi and psi 2 psi 1 star psi 2 that is psi 1 star psi 2 uh, plus psi 2 star psi 1. So this will become 2 times the real part of psi 1 psi 2 e power minus I omega t minus pi. This is only difference. The base factor only the difference. Now you can take a modulus psi of x and t squared. This will be 1 over 2 except the third term. I am keeping this as it is, this also as it is. Uh, this real part of this is, see, exponential term can be written as cos, that is e power minus I theta can be written as cos theta minus I sin theta. So you are taking real part of it. Then naturally this will become 2 times cos 3 omega t minus pi. Now what is the expectation value of x is equal to integral 0 to a x modulus psi squared dx. We have seen in problem 2.5 this is equal to a over 2 minus 16 over 9 pi squared. Instead of cos 3 omega t we are getting here cos omega t minus pi. Now we got this expectation value of x is equal to this one. that is a by 2 minus 16 over 9 pi squared cos 3 omega t minus pi. Now, in order to find the expectation value of momentum, it is equal to m time derivative of the expectation value of x. So, this is m time derivative of this expectation value. So, if you differentiate first term, you will get 0. So then next term is you have minus 16a over 9 pi square, and if you differentiate the cos 3 omega t minus pi, you will get minus sine omega. That is minus 3 omega sine omega t minus pi. So you will get this one. So here one minus, here one minus. Minus of minus will become plus. So 16a, you will get 16a 9 pi squared 3 omega, because minus and minus will become plus, sine omega t minus pi. Now you will replace omega. Uh, Omega is pi squared over h cross squared over sorry, pi squared h cross over 2 ma squared. We have seen in the earlier problem 2.5, and multiplying by 3. And of course, we have taken sine 3 omega t minus pi. Now we can cancel some of the thing. First, we cancel this m and this m, and it is 9 pi squared with this 3 pi square, which will become simply 3. Then you can cancel this 8 with 2, 16 with 2. And similarly, this a will get cancelled with this a squared, which will become a. So now in the numerator, you have 8 h cross, 8 h cross. In the denominator, you have 3a. And of course, you have sine 3 omega t minus pi. This is the expectation value of the momentum. Now we got the expectation value of x as a over 2 minus 16 over 9 pi squared cos 3 omega t minus pi. Now we will see some of the special cases. Let us say uh, now if psi equal to, sorry, pi equal to 0, this will become 0. You will get a by 2 minus 16 over 9 pi squared cos 3 omega t. When t is equal to 0, what will happen? You will get minimum, because here is minus. That is blue color. When pi is 0, it start from blue color, and it will oscillate like cosine wave oscillation. This will oscillate, go to maximum, and then it will come back. What will happen if pi is, we have seen what happen if pi is equal to 0. If pi is equal to pi, what will happen? Cos 3 omega t minus pi is minus cos omega t. So this minus will become plus. So when time t equal to 0, you will get cos 0 is 1. This will become a plus 2 plus 16 over 9 pi squared. It start with maximum, and it will oscillate. It will go on decreasing. So this is the one we have. So you can see the phase difference 180. This start from the lower value and goes up when time goes on. This is the other way around. It is up and goes down, and again it will go up. Exactly, pi equal to 0 is a blue color, and pi equal to uh, pi, that is, this is the green color. You will get the maximum value. Well, start with maximum, and then what about pi by 2? Cos theta minus pi by 2 is sine theta. So this will become sine pi theta. So what will happen when t equal to 0? Sine 0 0. it is exactly expectation value is a by 2. So it is exactly at middle. You can see it is zero point 0.5. Then it will oscillate like this. So this diagram, simple diagram, explain the time evolution of expectation value of x. Thank you very much for watching my video and supporting me continuously. Thank you very much.